I want to show you the parts I used to build the balloon tracker so you can see what all it takes to assemble one. One of the main components is the Raspberry Pi Pico board. And then we have the Traquito Jetpack. This is the actual transmitter board. And these two items are soldered together piggyback style. It's very easy to do. Then we have our solar cells. Of course, they're each a 1/2 volt, and we have 6 of them for a total of 3 volts. But at altitude, in cold weather, they're more efficient, and we get about 3.8 to 4 volts out of them, which is more than enough to run the assembly. I have a piece of purple styrofoam from Home Depot for the framework. It's just one piece of this and a couple of small pieces to hold various things, very small. Then we have our solder, of course, and we have our soldering station to solder the wires onto the solar cells. It takes exactly 270 watts on my system to accomplish that without destroying the tabs on the solar cells. This is the wire I use, a braid off of coax cable, and this is what it looks like after you've pulled it loose. Very small or fine wire. And this is the wire I use to interconnect everything on the tracker to keep it light. These trackers that I've been building for a while now come in at about 11 grams. So they're very light and work quite well for the balloon we're using. Here is the antenna wire that I use, and we've been using this for quite a while also, and seems to be working out quite well. We have been running 10-meter off-center fed dipole configuration on 10-meter whisper frequency. Here we have the modified Pi Pico board. I have cut this piece off, and then I modified it a little more, and I ground this edge off here to lose a little more weight. Now we're going to solder the tracker onto the Pi Pico, and we will use an alignment device, which is just a piece of wire. It's a little fussy to try to do, but we have alignment holes in both pieces. So right now I'm going to do the first step that I do. I'm going to solder the tracker board to the Raspberry Pi board. I have a clamp to keep them together. I have a modified paper clip here to align all the places that need to be aligned for soldering. There's 2 guide holes for doing that. This is mandatory for me so I can see what I'm doing. So I've got my soldering iron at 270 degrees, and I'm going to go ahead and solder 1 on each corner and then proceed to fill in the rest. And after I do this, I will test the Raspberry Pi board and load the software on it at my computer. Okay, I've got all the connections soldered, and that's what it looks like when you've soldered them correctly. And now to load the software onto the Raspberry Pi board. So now I'm going to plug in the Raspberry Pi Pico to my computer via a data cable, USB data cable. And this is what pops up. This is what's on the Raspberry Pi Pico. And now I'm going to transfer the file we want over to the Raspberry Pi Pico to tell the Pi Pico what to do. And it's this file here. So I'm going to drag and drop over to here, and it has successfully loaded it. And after it's loaded, you should get a green flashing light on the Raspberry Pi Pico, which it is flashing. So I've got the tracker connected back up to the USB cable, and I'm going to go into the user interface and check to make sure that the GPS system works properly. So we're going to connect, and it found it on COM5. So I'm going to click connect, and it says it's connected. Now down here, right here, is showing you the satellites that it's connected to. So it is working. It's giving us the date, or the time, GPS time, longitude and latitude, altitude in meters and feet, which is accurate, and speed and course direction is 0, as it should be, because the device is not moving. So that all works good. I will eventually have to edit in the call sign and the grid when we figure out what call sign we're going to use on this particular tracker, but it will be set up on 10 meters. So there you go. Now we're going back to the bench to continue assembling the solar cells. Now I'm going to show you how I apply a tinning coat of solder onto the solar cells, and this is my method. I saw somebody else do it, and it seems to work pretty well. So you have a flat tip on your soldering iron. We're going to put a little solder on the tip, just a little bit. Then we're going to lay the solder on here, onto the cell on that white solder strip. And then we're just going to go like that. And that applies a strip of solder to the cell, so you can solder your wire to it. Now I'm going to do the other side. One is positive and one is negative. Doing the same thing. Takes just a little bit of solder. If you overdo it, you'll ruin the factory surfaces there that the solder is applied to. And then you'll have to throw this away and go to the pile and get another one. Here are the cells with the solder strips tinned with your solder, and you'll notice they are done on opposite sides. So when you flip it over, you can daisy chain these together, positive to negative, positive to negative. Here is the first two soldered together with this really fine wire. And you can see I have a loop in there between each cell. That allows for expansion and contraction at -50 degrees at high altitude. Here is the assembled solar array, each one having a loop of copper wire between them to allow for the expansion and contraction, and a long wire on each positive and negative to run over to the tracker board when you get to that point. But that is the assembly. Now, with every bit of caution you can have, you carry it out into the sunlight and test the voltage output. It must be at least 3 volts or there is something wrong. Well, we managed to get it out here onto the towel. It's on the bucket in the sun. And we've got 3.28 volts, which is ideal. I can't express to you how careful to be with this assembly, or you will break these cells. Well, we're moving right along. I have the frame or support for the solar cells, and this piece will hold it all together. There's the call sign we're going to use on this tracker. And the tracker board is going to go in here like this. Like that. Now I'll glue it in place. But right now we gotta put the solar cells on here with a little bit of silicone glue. So I'm going to use these 2 pieces of foam here to support the assembly as the silicone is drying. So here's our solar cells. We're going to push them together to where they're pretty close together, just a small gap in between. Get them to where they will set flat. The little wire on there, the loop of wire is kind of makes it a little fussy, but you can do it. I do it, you can do it. We're going to take a little bit of silicone glue and just a dab on each area, just a spot of silicone, because you want the solar cells to be able to flex because of the changes in temperature. So we're going to put some marks here where we are going to put the silicone glue. This is very tedious. This is very tedious. So we're going to put a dab of glue there, 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 and so on. So these dabs of silicone are going to support the solar cells. So I've got the assembly with my blocks there. I'm going to take the solar cells and set them on top. And we want them somewhat centered. You do not want to apply any pressure to these solar cells at all, or they will break. I promise you, they will break. And it's okay if they're not perfect. And that's close enough for me. So we're gonna let that silicone glue cure up, and then we'll assemble the tracker into the framework. So we've got the solar cells attached with silicone onto the framework here, the purple styrofoam, and I've got the tracker siliconed into the framework with just a few dabs of silicone glue. We have connection points. This is B+, B- for the solar panel, and we have half of the antenna goes here, the other half goes here as a dipole, and then we have the GPS antenna, just one connection here, 2-inch antenna. There is no connection on here. So that's what we've got so far. Okay, now I have the solar panel connected to the tracker board. You can see the very small wire going from the negative connection across here, over here to the negative side of the solar panel, and the wire is glued down in several places. Now on the positive side, it's a lot shorter. We go from the positive connection down here and over to the positive side of the solar panel. Next is attaching the antenna wires. Now I'm going to work on the upper portion of the off-center fed dipole. This is 4 feet of bare copper wire, number 34, and it's going to go down through the straw and connect to the Traquito Jetpack tracker. Here's a close-up of the upper antenna wire. It's connected to the board now and goes through the straw. And this wire will also get glued appropriately with silicone, especially at the connection point. Here is a close-up of the antenna wire where it is connected to the tracker board. I've glued it at the actual connection point with silicone and then alongside the board to keep it from moving around, but not completely rigid. And then the wire, like I said earlier, will be going down through the straw. Now I have the antenna wires connected to the tracker. The shorter wire that goes to the top is 4 foot long. The longer wire attaches to the board and drops down to the bottom and just dangles loose in the air, which is 12 feet long. Here is the lower half of the antenna connection point on the tracker board. It's got the silicone on it already to stabilize it and keep it from moving around. And it goes down, glued to the purple foam, and comes across here and goes into a hole and wraps around another hole and comes out right here. So this is upside down. When it's in flight, this will be hanging down. And there'll be some silicone glue along this wire to stabilize it and keep it from flexing too much at the purple foam. Taking the results of the balloon flights into consideration, this tether seems to work really well. It's a little on the heavy side, but we're sacrificing a smidgen of weight for the use of this tether. Some people use the entire tether. This here is really hard to work with because you can't see it while you're handling it. I don't know. Yeah, you can see it here on the tracker. I have it suspended in two places by that spider fishing line. And it seems to work really well for that. I used to use it as the overall tether, but it was so hard to work with on the ground. You could not see it. And on launch day, it was impossible to see it. Very difficult to work with. Well, here it is, swinging in the breeze and transmitting. So it's a good test, good simulation. The tracker's running and being spotted by my own station. But the waterfall shows a very strong signal. The antenna is not completely unrolled. It's just working off the upper 4-foot section. But I'm very happy that it's working and transmitting properly and at the right time.